Hello students, this is video 6 of soil mechanics. This brings a discussion on the index properties and soil classification. Talking about properties of the soil, the total properties of the soil is divided into two groups in the broadest sense, such as engineering properties and index properties. Now the engineering properties are the properties which can be modified or improved as per the requirement of the engineer. On the other hand, the index properties are the properties which never change and therefore they are used to identify and classify the soil. The index properties are further divided into two groups, such as soil grain properties and soil aggregate properties. Now, soil grain properties are the properties which correspond to the individual soil solids and remain unaffected by the state in which the soil is existing in the nature. The most important soil grain properties are specific gravity and number 2, particle size distribution, that is diameter of the particle. Now the second one, soil aggregate properties are the properties which correspond to the whole mass of the soil, how the soil mass as a whole behaves, whether the soil mass is dense or loose, stiff or soft, etc. Hence, the most important soil aggregate properties are number 1, relative index or relative density for poissonless soil, of course. And the number 2 is consistency of soil. This is only for cohesive soil, clay soil, fine soil. Now, talking about all the properties, say specific gravity. Specific gravity of any substance is the weight of the substance of a given volume divided by the weight of the same volume of water at standard temperature and pressure. Similarly, for specific gravity of soil solids, we'll use the definition and try to find the specific gravity in the laboratory. So specific gravity of soil, particle size distribution, consistency of soil, all these can be determined in the laboratory. Today, we'll discuss about how to find the specific gravity of soil solids in the laboratory. We'll see with the figures and sketches. I will try to explain the method and the procedure of finding the specific gravity of the soil grains. Right? Let us see. Determination of specific gravity. The specific gravity of a soil can be determined by a pycnometer or density bottle. The process is briefly represented by the following schematic diagram. Now take one empty bottle or empty patnometer. Clean it and dry it, and then take the weight of the empty bottle, clean and dry bottle. Let the weight is W1. Next, fill the bottle partially with dry soil. Let up to this the soil is filled, and then with the partially filled bottle with dry soil, let the weight is W2. Next, with the partially filled bottle with soil, add water up to the top. Soil is already there. The remaining portion is filled with water. Take the weight W3. Mind it, in W3, the same bottle containing soil is filled with water and the total weight is W3. Last and finally, empty the bottle, remove all the water and soil from the bottle and fill the bottle only with water. Let the weight is W4. Now, W1 is empty bottle, W2 is bottle plus dry soil, W3 is bottle plus dry soil plus water, W4 is bottle plus water. This is water not completely filled. This is water with full of the bottle. Okay. Now, weight of soil solid only is equal to, see, W this minus this. This will cancel, only dry soil. W2 minus W1. Next, weight of equal volume of water will be this W2 minus W1 minus W3 minus W4. Weight of equal volume of water is W2 minus W1 minus W3 minus W4. Hence, specific gravity becomes GS is equal to weight of solids by weight of equal volume of water. This W3 minus W4, this is deducted from the W3, then water will cancel, this much water will cancel. Now W3 minus W4 gives you the difference of weight of water and weight of soil of the same volume. The difference if deducted from the only weight of this soil, then we'll get the weight of water of the same volume of soil. Specific gravity found out. This is the process.